All right, thank you very much for that introduction. Yeah, I am James, and hello, js.la crowd. Tonight we're going to be talking about building forms that your mobile users will love. And it's easy to come up with examples of form interactions or experiences that users on mobile devices will absolutely not love. I had originally done a version of this talk last year titled Building Forms Mobile Users Won't Hate. Same thing, but slightly more positive title tonight. Sometimes you go through a form and you're trying to type your email address and it's getting capitalized or spell checked. You try to create a username and it gets auto corrected. These are nice features on mobile devices in your Notes app or your email, but not when you're filling out a form. And tonight's talk might seem to you right now like a bit of a UX talk, but this is a part where Scoob and the gang pull the mask off, and it's actually accessibility under the hood there. Accessibility is what we're really talking about. And you might think, oh no, but it's user experience, right? And I want to kind of maybe help us put away a divide or a distinction that maybe doesn't hold true if we push it hard enough. And that is this: I think sometimes there's an unfortunate assumption that accessibility is for people with different abilities, like relying on a screen reader because of low vision or needing high contrast because of color blindness, etc. And user experience is for all the normal people like us. And that's absolutely not a helpful way to think about it. Anything that ends up in the apps or the sites that we deploy that causes friction, that keeps users away from the content they're getting to or the flows they're trying to complete, anything that puts friction in that way or a hurdle or an obstacle is an accessibility issue. It's slowing down somebody's access to the rest of the site or the app. This, for me, is a very personal topic. Like I said, I started the talk a year ago, but on December 28th, I was involved in a pretty bad car accident. Went off the highway in the snow and rolled a few times, and I broke both bones in my left arm and cracked a couple vertebrae in my neck. That put me into a mobile-only state of digital access for several weeks. I had to fill out all sorts of forms. I had to work with insurance claims and hospital billing and banking stuff, and it's all forms on the web. And I didn't have the privilege I normally do. I didn't realize that this was a privilege until then. I was saying, oh no, I'll just bookmark that and I'll hit it on my laptop later. With one arm broken, I couldn't hold or balance the laptop on my broken arm, nor could I type efficiently with one hand. I couldn't even rest for the first few weeks an iPad against my broken arm and try to use it as a prop. It just hurt and was too swollen. And so for me, this became a very personal thing. And I realized how true it is. What Cindy Lee, an accessibility researcher and expert, has said: we're all just temporarily abled. Accessibility ability levels is not a matter of permanent disability or not. Different things, parts of our context, the device we're using, what's going on in the room around us, all affect and can constrain our ability level. You have a different experience if you hit a website on a desktop versus on a phone versus tapping away on the front of your Samsung smart fridge. They did not pay me to say their name. It's a different experience if you're tapping with your finger or using a mouse or another really fine pointer device. Low vision, relying on screen readers. Here's a fun one. Some people have a condition that causes their hands to shake, tremors. Parkinson's is an example of that. Some people are riding in a bus or a car through a bumpy part of town, a poorly maintained highway, a gravel road. They're in an airplane during some turbulence. They have the same result. They can't tap and swipe precisely, whether it's because of a health condition or because of just where they are in transportation at the moment. Sometimes an injury changes our ability level. That was my story. Sometimes it's just a distraction. You're trying to fill out a form, you get into things, and all of a sudden a kid or a coworker or a partner comes into the room, asks a question, you look back, and you've lost some context. It just flipped out of your memory real quick because we don't keep that in RAM very long. And all this complexity sometimes leads us to think, oh gosh, accessibility. If the challenges are this varied and this complex, the solutions are just as bad, am I right? And that I empathize. That sets us off. That makes accessibility seem like a big, hard topic to get into. But what I want to propose for tonight is a way to look at a simpler framework And I use simple as a contrast to complex, not as a way to assume that it's basic knowledge that everybody should have already, but a more unified, less complicated way of understanding accessibility. And that is through browser semantics as our contractual API on which everything else relies. So this is a big takeaway: use semantic markup. And there are some huge benefits here. When we use semantic markup, that's the contract that browser vendors have with the HTML and CSS and JavaScript spec organizations and maintainers. Screen readers have a similar contract to implement things in a standard, consistent way. When we use semantic markup as our starting place, we get to worry a whole lot less about ARIA. And you might be thinking, wait a second, isn't like accessibility all about putting the right ARIA attributes on the right things? And sometimes, yeah. I did a talk a couple years ago on accessible modal windows, and because that's a really unique user interface, you do need a handful of ARIA attributes to have an accessible mobile dialog box. But often you don't. Everybody likes to talk about the big example of use a button, don't use a div with a click handler. And yeah, you have to put roles onto the div. If you want it to act like a button, you have to do things like keyboards to work correctly. It's so much extra work, how it responds to space and enter keystrokes that come for free when you're in a browser that just knows what a button is, which is all major browsers for like the last several decades. As long as there have been browsers, they've more or less understood what a button is and agreed on it. So we get to worry less about ARIA when we're dealing with regular HTML attributes. That's what we're going to talk about tonight. In a minute, we're going to talk about 3 attributes that are going to make our mobile forms amazing, and then look at a handful of quick use cases on how to put them into action in our apps. Second huge benefit is when we focus on semantic markup as a foundation, we write less JavaScript. And again, this may be weird for me to show up at a JavaScript meetup and say, hey folks, here's how you write less JavaScript. But isn't that what we all want, really? The less JavaScript we have to write to get our job done, the quicker our job is done, right? We can either be more efficient or have a little more time to ourselves, however way your workflow works. When you write less JavaScript, you also have to write fewer tests to make sure that all the JavaScript you've written isn't breaking. That's also a huge win. Writing less JS equals writing fewer tests. And then finally, if you write less JavaScript, that's a smaller bundle you're publishing, and your users get a slightly quicker app. It's a performant thing to do. So yeah, it takes so much extra JavaScript to make a div behave like a button or a span behave like a link, no matter how you style them. Just my recommendation, just use the semantic elements and style them. CSS right now is more than capable of making a button look however you want it to. And the third big win when we focus on semantic markup as our foundation, our starting place, is that we future-proof our apps. If I asked you all to name all the interfaces that a user might access a site or an app you've deployed through, we might start with things like browsers. We might move on to screen readers or other assistive technology. We might include some plugins or some operating system techniques that increase contrast, but still kind of in the browser category. We might get really creative and start things like, oh yeah, you can view a little bit of a web page on a smartwatch sometimes. What about VR headsets? What about the technology that's going to be released, invented, and produced in the next 3 to 5 years that we don't know about yet? If that technology is going to serve users web pages, that's a browser, it will contractually need to conform to HTML specifications, which means if we're using things like buttons and selects and inputs and all the right semantic markup to begin with, nobody's going to produce, I hope, please nobody prove me wrong, nobody's going to produce like some VR headset that has no concept of what an HTML button is, but still manages to show you a web page sometimes. If we stick with the semantic basics, no matter what devices get invented or released in the future, we're covered already. So here's the foundation. The baseline, if you don't do anything else, always make sure every form control, and by form control, I mean input, text area, or select, make sure every form control has a label semantically attached to it. The quickest way to semantically attach the 2 elements is to wrap the label around the input and the label string. This is the code golf winner, fewest keystrokes here. Usually, however, we opt for this pattern. We use a for attribute on the label that matches the ID attribute on the input, text area, or select, because typically we're conceptually thinking of these and styling them as siblings, not nested. But these are the foundational patterns. We just have to do that. Don't do anything clever or creative beyond this. This is the best way. When we semantically associate our labels with our inputs, the browsers do a bunch of amazing things for us. For example, if you ever click on a label, the input will activate. Focus will be automatically placed in the input. In an input that's a type radio or checkbox, when you click on a label that's properly connected to the input, clicking the label, that entire paragraph of text, however long it might be, a word or a paragraph, will automatically check or uncheck the radio or checkbox element. And we've all been on a form that's frustrating when they don't associate the text correctly, and you have to find that tiny little like 15 by 15 circle and just get your finger right in there on a mobile device. It's really tricky. So don't make users do the tricky thing, make it easy. Additionally, users who come with screen readers or other assistive technology, as they navigate through the page using a keyboard or other scroll input device, as they advance through the page, when they focus on an input, the label is automatically announced to them. We don't have to do anything hard or challenging or tricky in JavaScript to get this to happen. This is just the way browsers act, and we get it for free when we use semantic linking between our labels and our inputs. And I did want to handle one more pattern that's really common, and I think it's worth mentioning. We often want to attach an extra paragraph of text to an input. Maybe it's descriptive text that shows up ahead of time, telling people how long to make a username or what special characters to put in their password. Maybe after validation attempt, we've got a red paragraph that's telling them what went wrong with a given input and what they need to do to fix an error. To semantically associate that paragraph with the input, we keep the label and input attached like normal with for and ID, but then we give that paragraph of descriptive text an ID of its own and stick that string into aria described by on the input. And it kind of looks like a little bit of daisy chain. Labels for points to input ID, input aria described by points to paragraph ID. And when you do this, people who can read the page with their eyes will see the paragraph as the page loads or the UI changes. And people who rely on screen readers will have that paragraph of descriptive text announced to them as they navigate to the input without getting to the input, trying to fill it out, then navigating to the next thing on the page, which is a paragraph which tells them everything they did wrong. And now they're frustrated because they have to go back and fix something with information that we could have given them ahead of time. So this is our foundation for how to associate labels and, when necessary, descriptive text semantically connected to an input. Now the 3 attributes I promised. These are HTML attributes. We're not going to talk about any more ARIA attributes. This is just standard HTML. And the first one probably is familiar to you all. I'm guessing high 90% of folks in the room have used the type attribute. The type attribute goes onto an input, not select or text area, just input, but it semantically identifies what kind or type of content or data the input accepts, and then passes along through form submissions or a value property. Occasionally, this can suggest more specific labels to screen readers. So using the right type on an input gives assistive technology extra information to surface to users as the user settings and the software for the assistive technology are working together. Got a screenshot for you here from the HTML specification under the Accessibility API Mappings heading. Not because I want you to memorize a dry, boring chart, because you're probably blinking and being like, okay, dry, boring chart, cool, next slide, please. Sorry, I don't want you to memorize a chart. I just want to show something here, which is these 4 rows underneath the first one are all different accessibility models that are implemented by different accessibility or assistive technology software. AX, I think, is VoiceOver. MSAA is Windows 1, I think. JAWS, perhaps, not positive. But anyway, the takeaway here, though, is that when we use the right type, in this case, the type is password, there's extra information, including extra descriptions under the AX heading that are passed along to screen readers and can be surfaced to users, making their life easier as they're filling out a mobile form. So yeah, always use the right type. Autocomplete is a blast. I love autocomplete. And this tells browsers and mobile operating systems, the actual OS level, what user data to offer as an autocomplete option. These hints are consumed by plugins like LastPass, 1Password, your authentication management plugins, as well as by your actual mobile operating system, Android or iOS. And this is also mapped to accessibility state according to the AAM. And that state supports autocompletion in a couple of these accessibility models. And this means that accessible or assistive technology can announce to users, autocomplete is ready to go. Here are your autocomplete options with a little more information than if we didn't bother including any autocomplete data. There is an ARIA autocomplete attribute, but it's less consistently supported. So sticking with the native HTML, autocomplete is preferable. And the third attribute doesn't do anything for accessibility at all. And that's great because it's presentational. It lets us tell mobile operating systems what the best on-screen keyboard to display via software. And, except for Blackberries, everybody's showing the keyboard with software, not with hardware. But it tells the operating system what the best keyboard is to show users as they're on this particular input. It doesn't have any accessibility mappings, so it doesn't have any drawbacks. We can keep things accessible and semantic with type and, if necessary, autocomplete, and use input mode to tweak the keyboard display without compromising any accessibility or semantic information. So, as promised, here are the use cases. And here's where we're getting a handful of code blocks. The pattern here on these slides will be code block, Android in the middle, iOS on the end. And as we get into the autocomplete, I apologize that my Android screenshots come from an emulator where I could not set up a contact card. But I did confirm with Android using friends that Android does a perfectly fine job showing autocomplete options. And it's not like it's an iOS only feature. Don't want anybody to accidentally conclude that based on the fact that my iOS screenshots do have autocomplete, but the Android ones don't. It was just a limitation of the emulator I was using, sorry. But here's a username. We want users to create a username when they sign up. We want them to enter a username when they come back to the site. The type here is text. There's nothing semantically fancy about a username, so text is all we need there. The autocomplete value is username. That will send the right signal to, as I mentioned earlier, password completion plugins, as well as anything else that, if you've got handles for various logins stored in your contact card on your phone, you might get that information as well. What you might notice here is that the two keyboards in the screenshot both have lowercase keyboards, which is what most users want for creating a username. Not many people want to start off with a capitalized keyboard and have to hunt for shift just to downgrade everything. We've fixed that by using the attribute, and these are the 3 bonus attributes that we're only using here, and I'm not going to spend a lot of time on, but auto capitalize none. That tells your browser, your mobile operating system, not to capitalize the keyboard by default. Autocorrect is off and spell check is false. And if I ever meet the HTML specification crowd, I want to ask them why they picked 3 different negative values for these 3 properties or attributes. Probably because they were all specifications authored by 3 different people would be my guess. But yeah, that's how we got lowercase keyboards here so that users aren't frustrated trying to fight autocorrect or spell check or capitalization as they're generating a username or re-entering it. Email is super common. There is a semantic type for email addresses, and that is, as you would guess, email. Sorry, very basic slide. Autocomplete can also be set to email. And now any email addresses you've saved in your contact card on your mobile device will be presented by your operating system as autocomplete options. And this all happens operating system level for security's sake. The browser isn't told all the email addresses you've got in your contact card. It just gets whatever one you typed copied into the field. And as you'll notice, our mobile operating systems are pretty intelligent here, and they've already lowercased the keyboard, and they're also going to be disabling autocorrect and spell check because of the type set to email. We didn't have to use those 3 extra presentational attributes because we used type equals email, the semantic thing we needed to do for a foundation, and we got all those other operating system features for free because iOS and Android do a great job knowing what an email address should look like and what it shouldn't. Telephone numbers are fun. There's a type for that and an autocomplete value. They're both tel. And you can see this automatically brings up a 10 key with tiny letters, just like a physical printed telephone. Addresses are cool. The type is text. There's nothing semantically fancy in the HTML specification for a street address. There are several autocomplete values, however, that are useful. I've demoed street address in this code block. Also, there are autocomplete values for city, state, zip code, and country. And the great thing about that is we've already kind of demonstrated that it's great to give users the right on-screen keyboard. Even better than that, give them the right autocomplete option so they got one tap. And one step better than that right here on this slide is let them fill out 5 or 6 fields in your form with one tap. The mobile operating systems will present your entire address from your contact card and fill in all the relevant fields, provided they've got the right autocomplete values. And even maybe provided they don't, operating systems are pretty smart and they guess relatively well. But for safety and for user smooth experience, we can specify these autocomplete values and get 5 or 6 fields filled in with one tap. I love that. Numbers are fun. Numbers need a little bit of attention. You might think, oh yeah, type is number. That's great for credit cards and authentication codes and prices and quantity in a shopping cart and anything that's a number. If they type a number, give them a number. Actually, the HTML specification tells us not to do that. The type of number is inappropriate for strings that just happen to contain numbers, like credit cards, postal codes, validation codes, two-factor authentication codes. I like to think of it this way: type number is for any number that needs to be used in a calculation. So shopping cart quantity, type number is semantically awesome there. Price, I think there most of the time. Credit card, no, not quite. But what should we do? Because we really want to make sure that when we ask people to type in their credit card or a two-factor authentication code from an SMS or an app, or the validation code from the back of their debit card, we want to make sure we give them that number keyboard. We use typed text on the input, but we add input mode decimal. And remember, I talked about input mode is awesome because it lets us do things presentationally with the on-screen keyboard without any semantic drawbacks telling a user incorrect information about the actual semantic value type of the field. So use input mode decimal, and boom, we get number pad. There's another one, input mode numeric, and there are some real nuanced details between how iOS and Android handle those differently, and that's not really in scope for tonight, other than decimal is probably a safe choice. And if you really want to test numeric and you got time, go for it. I think the only difference is probably that on Android, numeric adds the tiny 3 letters. That might be the only difference I recall. But read the link here, the gov.uk number inputs article, if you want to get a deep dive on this. It's fantastic. It covers the user experience and the accessibility issues with the number input, and it's just a treasure trove of data if you're handling number fields, whether that's credit card or two-factor authentication codes. We got the same pattern here. Type as text. It really is just a text stream that coincidentally happens to only contain numbers. So input mode is decimal to make that easy to type. And then autocomplete is one-time code. And this will send the browser the hint it needs so that it can tell the operating system, I'm listening. If you have any two-factor codes while you're reading this user's text messages, send them my way. And that allows the operating system to create that secure glue between your text messages or your authenticator app coming in and your browser. Date is another one that's a little tricky. Type date is your safe, simple, easy one, right? This is semantically valid. It does come with some accessibility issues that have been documented, inconsistent support with screen readers and even browsers. And also it's got some usability issues. On Android, the date picker is this tiny little rectangle of a calendar grid, and the tap targets are tiny and too close together. Again, tremors, transportation, anything that makes you tap or swipe less precisely, the date picker on Android is going to be terrible. iOS and Windows Surface, not much better. They use a UI pattern that I like to call the scrolling barrels of users hate these, which is those 3 kind of spinning columns where you get day and month and year. And if you're typing too much and you can't control the inertia, it's just a mess. The inertia really flies and you have to slow it down, and it takes 2 or 3 times to get there, to overshoot, scroll back, and not a fun experience either. So if you want to get around these UI problems and give users big, easy, tappable ways to complete a date field, what I recommend is this whopping code sample. Sorry, this is a long one, but it's the last one. So we get through this and we're in the clear, y'all. I call this a compound input pattern. We've got separate inputs for month, day, and year. We're using the type text input mode decimal so that we get numbers that are big and easy, that nice 10-key keyboard for users to tap. And then we're making sure that screen readers and browsers know that these 3 fields are all connected to each other by wrapping them in a field set with a legend, and the legend serves as a meta label for the entire group of correctly labeled inputs. And there's more. There are types and input modes for URLs. There are autocomplete options for all your credit card data, like the number, the expiration date, the validation code. There's even a way to give users birthday in one tap autocomplete, all sorts of fun stuff. And again, on the slides that talked about each of those attributes, type and autocomplete and input mode, there's a link to MDN, Mozilla Developer Network documentation, and you can find all the available values for these 3 attributes on those pages. So to wrap it all up again, we're solving our accessibility issues and our user experience issues at the same time by addressing things on the semantic markup level. And the awesome results are we're improving our UIs right now for all the technology that our users currently have in their pockets. And we're future proofing the apps we build, the UIs we're creating for years and devices yet to come.